Sorry, girls. Let's continue on this. So therefore, the angle of inclination is actually 180 degrees minus 59 degrees. That will give you 121 degrees. That means this angle is 121 degrees. Now I repeat it, because 121 is an obtuse angle, is in the second quadrant, so therefore tan value of 121 has to be less than 0, which in this case that would be roughly negative 5.3. Okay, so therefore if this is 121, that means this has to be 59. So what does that mean? That means triangle ABO is an isosceles triangle. Okay, so this is a very typical example of using the angle of inclination to figure out something. All right, so the next part we'll focusing on gradient again. So there are two theories about gradient, using gradient as applications. First one, two lines are parallel only if they have the same gradient. In other words, L1 is parallel to L2 if gradient of 1 equals gradient of 2. Okay, and another important fact which I have done before, two lines are perpendicular, which means they cross it at 90 degrees, only if the product of their gradient, the product of their gradients is minus 1, i.e. L1 is perpendicular to L2 if M1 times M2 is equals to negative 1. Okay, so let's take a look at an example. Remember, all of this has been done in year 10. Here is simply just a revision. And if you don't remember, pick it up right now. So, show that the points A, which is 3 and 6, B, 7, negative 2, C, 4 and negative 5, and D, negative 1 and 5, form a trapezium where AB is parallel to CD. So to prove that, basically you have to show AB parallel to CD. In other words, you have to say, or you have to show the result, the gradient of AB equals the gradient of CD. So the gradient of AB equals, remember here is given the coordinates, so therefore use y2 minus y1 over x2 minus x1. So therefore that is negative 8 minus 4, that will give you negative 2. And let's take a look at the gradient of CD that will give us is, C and D is here, 5 minus negative 5 over negative 1 minus 4. The top gives us 10, the bottom is negative 5, which is negative 2. Okay, so therefore now we have the same gradient. That means therefore AB is parallel to CD. And in other words, therefore ABCD is a trapezium? Because the definition of trapezium is there's at least one pair of opposite parallel sides. So in this case is A, B, C, D. Like that. Okay, now let's take a look. Perpendicular on the other hand. Now, example. Okay, so given the 4 points, A, B, C, and D. Well, not quite given because D has a unknown in there. Let's find A, the value of A, which is the x coordinates of D. And the coordinate of D if AB is perpendicular to CD. In other words, AB crosses CD at 90 degrees. Okay, remember the condition for two lines to be perpendicular? It's the product of their gradient multiplied together equals -1. So the gradient of AB using the rise over run definition, y2 minus y1 over x2 minus x1 would be, that's 10 on 8, 5 on 4. Yep. And the gradient of CD on the other hand, we have -1 minus 8. On the other hand, it's A minus 0. Now, unfortunately, we don't know A, but that's okay. We will figure that out in a minute. -9 on A, so that is -9 on A. Oops, my A looks like a 9. So, since they are perpendicular, since AB is perpendicular to CD, which is given in this case, therefore, the two gradients multiplied together should be equals -1. -1. Now we'll just put them together. Therefore, 5 on 4 multiplied by -9 on A equals to -1. So negative cancel each other out. We have 45 over 5 for A equals to 1. Yep. So therefore, A equals to 45 on 4. So therefore, the coordinates of D is 45 on 4 and -1. -1. Okay? This is how we're using perpendicular through the definition of gradient. Now, another important stuff we need to do today, it's how we actually use the definition of parallel lines to prove something else, collinear points. Now, collinear points are the points lie on the same line. So for example, in this case, if I have something like that, A, B, C, this is the first one. So therefore, point A, B, C are collinear because they are on the same line. Okay, so however, if I have point A, point B, and point C in here, oops, that means they are not on the same line. So A, B, C are not collinear because they don't lie on the same line. And how are we going to use the definition of parallel lines to actually figure it out? It's actually quite straightforward. So if, for example, if the gradient of AB equals the gradient of BC, then A, B, and C are collinear. Why is that? Because you can see there is a common point here as B between the two straight line or two interval. And if you have a common point and these two have the same gradient, which means they are parallel, of course they are on the same line. There's no other way. And obviously if you have the same common point B, if they don't equal to each other, in this case, then A, B, and C are not collinear, which means they don't lie on the same line. And please highlight this part because it's a major method that we're going to use to prove collinearity in 3-unit or even in 2-unit. Okay, so let's see an example. Remember, this one can only be used when you have a common point B. If it's AB and CD, you're simply proving parallel, nothing else. Nothing else. Okay, here is an example. Let's test whether A, B, C are collinear. It doesn't matter which one you make it as a middle point as far as you have one common point, and if the gradient are the same, that means they're collinear. Okay, so to start, you just go gradient of AB, which is, let's go 3 minus 5 and 1 minus -2. That is -2 on the top, the bottom is 3, therefore -2 on 3. Okay, and you can take gradient of BC or AC, doesn't matter, let's just take BC. Gradient of BC is y2 minus y1 over x2 minus x1, that is 4, sorry, -4, and that is 6, therefore -2 on 3. And in this case, since m gradient of AB equals to gradient of BC, therefore the points are collinear. Okay, again, most of the stuff in here about gradient we have done before. We're just reinforcing the idea about angles of inclination using the concept of parallel and perpendicular, and also introducing using the definition of parallel lines to prove whether the points are collinear. And the homework will be exercise 5, sorry, it's Cambridge, obviously. Let me take a look. 5B, questions. Three, 5, 7, 8, 10, 11, 12, 15, 16, and 18. Okay, so this will be your homework for Thursday or Friday, depends on which day you have it. Good luck, girls.